Okay, in this video, we're going to answer this question 8 in IGCSE, May, June 2021, paper 3 in the core curriculum. And the code number for the paper is 1521/32. That is May, June 2021, paper 3. If you want to follow along, you can download it and follow along. The question says the area of land is in the shape of a quadrilateral ABCD. The scale drawing shows the position of A, B, and C. B is 120 meters from A on a bearing of 60 degrees. And the scale is 1 centimeters represent 20 meters. Okay, this is the shape here. Based on the information given there, see the bearing of B from A is 60 degree. You can see it's indicated there on the diagram, 60 degree. And B from A, the distance is 120 meters. Then what do they want us to do? Let's flip over the paper to the next one. It says, question 1 says, find the actual distance BC. I've actually answered that already. Let me show you how I got to that, 190 meters. The actual distance BC, we need to measure the length of that line BC to get the actual distance. So, place your ruler in a way that the zero mark is on B, point B. Then you measure down to point C. Based on what I'm seeing on my ruler is 9.5. That is 9.5 there. And then you go back to the scale of the graph. Or is it graph or scale drawing? The scale says 1 centimeter represent 20 meters. So if 1 centimeter is 20 meters, what would the 9.5 we just measured, what would that be? 9.5 will be, since 1 centimeter, 1 cm is 20 meters. That means 9.5 cm, let it be x. By simple proportion, we can find the value of s. And how do we do that? Cross multiply. 1 multiply x, 1 times s is x. And then 9.5 times 20. 9.5 times 20. 9.5 times 20 is 190 meters rather. So converting 9.5 centimeter to meters, we have 190 meters. So the distance BC, the actual distance BC is 190 meters. Then the question 2, that is A2, say measure the bearing of C from B. The bearing of C from B. How can we get the bearing of C from B? Bearing of C from B is talking about this angle here. Remember, we measure bearing from north and then go in the clockwise direction. So this very angle here is the bearing of C from B. I hope that is what they asked us to do. C from B, yes. So C from B. That to get that angle, we need to make use of protractor. We'll get our protractor and place it in a way that the baseline of the protractor is on this very line here, the reference line, which is north. This line pointing north, the baseline must rest on it. And then on the protractor, the baseline and 90 degree intersect at a point. What do I mean? This is the baseline on the protractor, and this is 90 degree here. Where the two lines meet, this very point, where I'm touching now with a pencil, it must rest on this very point also before you measure your angles or your angle. So I place it Make sure you place it well enough. Okay, I think that is okay now. Then we read the angle all the way down to the line. Based on what I have here on the line, I think it has shifted again. Let me adjust it. What I have here is 105. So the angle is 105 degree. The bearing of C from B is 105 degree. Let's write it here. 105 degree is the bearing of C from B. Then question B says D is the point such that angle BCD is 60 degree and CD is 210 meters. Okay, angle BCD, where is angle BCD in the first place? BCD, that means based on that information, here is C. There should be a D here somewhere here. That is 210 meters, 210 meters from C according to the instructions. So we are going to have a line that come like this, and then this angle will give you angle BCD. So how can we get that? We are going to use this line now as a reference line and get an angle of 60 degree because they say BCD is 60 degree. So with our protractor placed on this line, we'll place it in a way that the baseline of the protractor, must be on this very line, and then when baseline and 90 degree meet, will also be on this very point here, point C. So I'll place it this way. This is not there yet. Let me shift it. The flashlight is affecting it. Okay, I think we are there now. So here we're going to read from this side. Since we want to measure 60 degree, BCD, the line is going to come this way. So I'll measure from here down. Here is my 60 degree. 60 degree. Let me shift it so you see it clearly. Let me shift. The thing has shifted again. I think it's there now. So here is the 60 degree. So I've placed a mark there on it. That is my 60 right there. You can see 60 and 120. So when you are going in the anti-clockwise direction, you read the base measurement here. 60 degree, put a mark there, and then connect that mark to point C. And recall that they said that line CD is 210 meters. So 210 meters will be how much in centimeters? Go back to our scale, which is, the scale is right here, 1 centimeter to 20 meters. So if 1 centimeter is 20 meters, how many centimeter will be 210 meters? Let's do simple proportion again. 1 centimeter is 20 meters. So let x centimeter be 210 meters. Again, by simple proportion, we'll cross multiply again. 1 times 210 is 210, and s times 20 is 20s. So 20x is equal to 210. S therefore is equal to 210 divided by 20, and 210 divided by 20, that will give us 10.5. 10.5 centimeter is the required line that will make up CD. So I'll place my ruler, connect the point that we drew earlier, or that we marked, not drew. This is the point here. So make sure that from the required length of line is 10.5. So that is my 10.5 mark there, right on point C. And then I will draw a line. Make sure that the line passes through that point that we put for angle 60 degree. It's not good enough. Okay, we'll manage that. So that is angle 60 degree right there. This angle here is 60 degree because it said BCD. BCD. Here is our point D. And label point D. That is point D right there. Now, what do they want us to do again? Say complete the quadrilateral. Complete the quadrilateral ABCD. So we've gotten all the points required. We've gotten point A, B, and C already drawn for us. And based on the instruction given to us, we are able to get point D. So the remaining thing is to connect point D to point A to complete the quadrilateral. So with your ruler, draw a straight line from A to D to complete the quadrilateral. A to D. That is a quadrilateral drawn. Okay. Then the next question is, question C now. E is a point on CD. Where is CD? The CD is the point or the line that we drew. This line CD. Now they say E is a point on that. E is a point on CD and it's 4.5 centimeter from C. That very point is 4.5 centimeter from C. So where is C? This is C right there. We mark a point that is 4.5 centimeter away from it. So let me get my ruler again and do that. 4.5 centimeter. To turn the ruler upside down. Or better still, let me turn the paper. 4.5 centimeter is the point. Okay. Here is my 4.5 centimeter, and that is point E. There is point E right there. That is point E. What else do they want us to do? They say draw an arc of a circle, center C, radius CE from the line CD to the line CB. Okay, draw an arc of a circle, center C. This point should be the center of the arc. This point should be the center C, and then the radius should be CE. The radius should be CE. That means from here to here we form the radius of the arc. Okay, and then we have to draw that center C, radius CE from the line CD to the line CB. Okay, so how do we do that? We need a pair of compasses with the steep point of the compass placed on point C. We extend the pencil point to point E. Sorry, my table is very slippery. Let me place it right there. I think you can see it like that. So we extend the pencil point to point E. There is the radius there. Then we have to draw that to line CB also. Let's check that again. Draw an arc of a circle, center C, radius CE from the line CD to line CB. Okay, so line CD to line CB. This is line CD. Line CD is right here, and then line CB. So the circle, or the arc rather, we start from this point and then go all the way like this. That is the arc right there. That is the arc drawn. Okay. Then the next part of the question says, as the last part of that question, calculate the length of this arc with sector angle of 60 degrees. Length of arc is given by the formula, because I've covered that in one of my videos. Length of arc, and I'm going to leave a link to the video in this. Length of arc is given by L equal to theta over 360 times 2 pi r, and theta according to this instruction is 60 degrees. So I have 60 divided by 360, 60 divided by 360 times 2 times pi is a constant, approximately 3.142, times the radius is given right there, 4.5. Remember, E is a point on line CD, and E is 4.5 centimeter from C. It is that very 4.5 that forms the radius of the circle, as you can see here. Line CE, the radius of the arc, not circle. Well, that means I have 4.5 right here. Theta over 360, theta is 60 degrees. So 60 times 2 times 3.142 times 4.5 is 1696.68, and divided by 360 degrees, that is 4.7 approximately. So the length of the arc is 4.7 centimeter approximately. Now, that is the end of that question. I hope you found it to be useful. If you do, don't forget to subscribe to the channel so you get more of this. And you can also share it with your learned colleagues. As you do, be blessed.